Welcome to my video series of database management system. In this video, you will be learning about ER model or ER diagram. This is my fourth video on ER model. In the first video, I have created a detailed video on what is an ER model, why we need the ER model, and what are the different shapes by using which we can create the ER diagram. In second video, I have talked about in detail what is an entity and what are the different types of entity. In the third video, I have given the detailed description and I have given the explanation about the what is an attribute and the types of attribute. Now in this video I will be talking about, this is a lecture 4 on ER model. In this video I will be talking about the relationship in ER diagram. So relationship is a one of the component of ER diagram. What was the two more? The first was entity, next is attribute, and this is the last component of ER diagram, that is relationship. So in this video you will be learning about what is a relationship, types of relationship with an example. So I request you, please stay tuned till the end of this video. Please subscribe to my channel, like and share this video. Thank you. In this video of my ER model, the lecture 4, I will be teaching you what is an ER model with example, the components of ER model, what are the different components, the components entity, attribute and relationship. This video is purely based on the last component of ER diagram, that is relationship component. So I will be telling you more in detail about what is a relationship and types of relationship with example. So let's start. Let's see what is an ER model or what is an ER diagram. Both are same. ER model. ER model stands for entity relationship model. Entity relationship model. Entity is a real world object relationship, how the real world objects are having a relationship among themselves in a database. So this model is used to define the data elements and their relationship for a specific system. For example, I have a company of some production. I have some production company. So in that production company, I will be having different departments on the different data elements. So how these data elements will be communicating among themselves will be specified in our database model. The ER model defines the conceptual view or design or blueprint of a database. Conceptual view or design or blueprint. It means that before creation of a database, we'll be having how the database look like, how the different elements of a database will be communicating. So in detail, the ER model will define everything, how our data elements will be having a relationship. So it is a high level data model. ER model is a high level data model used to model logical view of the system from data perspective. What is a data perspective? How the data should be visible, how the data should be communicating, how the data will be communicating with other data. So it's a high level data model purely based upon data perspective, having below components. What are these components? Entity is one component, entity type is one component, and entity set. So in detail I will be telling about what is an entity, what is an entity type, what are entity sets. So in ER modeling, database structure is portrayed as a diagram called entity relationship diagram. Whenever we are going to create a ER model conceptual view, it's nothing but a diagram. So that diagram is going to portray the basic structure, how our database look like, An entity relationship model, that is ER model, describes the structure of a database with the help of a diagram which is known as relationship diagram, that is ER diagram. ER modeling helps you to analyze data requirement systematically to produce well designed database. So without ER modeling, we cannot create a database. It will help us to analyze the data requirement systematically, to analyze the data requirement systematically, and based upon our analysis we can produce well designed database as per the requirement. So let's see this example of ER diagram. Let's consider I have a table, student table. So physical table, I have a student table wherein I have columns or the field names such as student roll number, student name, and its phone number. Let's consider I have another table college where I have the fields such as college code, college address, and a phone number. Now, how these two tables are in relation? As we know, students will enroll into the college, will enroll into the college for to learn some course. So we can say student studies in college. We can say student studies in college. So studies will be the relationship between student table and college table. So this is an table representation. Let's consider the same thing with our ER model representation, diagrammatical representation. Student table. So here student table will be called as student entity in relationship model, that is ER model. So student is an entity having the attributes student roll number, student name, and student phone number. So all these are attributes of our student entity. And I have a college entity. The attributes of college entity is college code, college address, and college phone number. All these are its college entity attributes. So this is my student entity and college entity. In the above you can see student table and college table. So in ER diagram we'll be having entities. So student entity and college entity. So student entity having its own attributes, college entity is having its own attributes. Now what is the relationship? The relationship is student is going to study in college. Student studies in the college. So studies will be the relationship between student and college. So this is a basic example of our ER diagram. Let's see the components of ER model. So what are the different components? So in ER model, we have seen entity, attributes, and relations. So these three are our major components. These three are our major components of ER model. So what are these components? Entity, attribute, and relationship. So every entity will be having attributes. What is an attribute? It's a characteristics of an entity. Characteristics of an entity. So I have three components of ER model, that is entity, attribute, and relationship. So let's see this entity. So entity is of two types, strong entity and weak entity. Strong entity and weak entity. Attribute. So attribute will be of four types. First, key attribute, composite attribute, multivalid attribute, and derived attribute. Next, coming to relationships, I will be having unary relationship, binary relationship, and n-ray relationship. With respect to this relationship, I will be having the cardinality constraints such as one to one, one to many, many to many, many to one. So all these are my cardinality constraints with respect to my relationships such as unary, binary, and n-ray. Let's see the last component of ER diagram or the ER model, that is relationship. What's a relationship? The association among different entities is called as a relationship. Is called as a relationship in our ER model. So we'll be having different entities in an entity set. How these entities will be having an association among themselves will be defined as an relationship. Will be defined as an relationship. So we will be having a relationship set. So what is a relationship set? We will be having similar kind of entities in an relationship set. For example, if I have an education institute, In an education institute, I will be having a faculties, students, and courses. All these are three different type of entities of having the same subject concept, that is education. So if I have a relationship among these all, it will be called as a relationship set. They are of similar type. Next we have the degree of relationship. Next we have the degree of relationship. The number of participating entities in a relationship defines the degree of relationship, such as unary, binary, and n-ray. So unary means only one entity will be there in relation. Next, binary, two entities will be there in a relation. N means more than two, that is three or four entity sets or entities will be there in a relationship. Next, we have the mapping cardinalities. Mapping cardinalities. Cardinality means how many times a one particular entity can be in association with other entity. For example, one entity can participate or have a relationship with another entity one time or two times or many times. For example, a student can enroll into multiple courses. So it means one to many, right? Next, a student can opt for a single university. So student is in one entity, university is one entity. So one to one. So like this, cardinality is going to define how many number of times an entity is going to be in association with some other entities. So relationship. So relationship is of three types: unary, binary, and n-ray. Unary means degree is 1, binary means degree is 2, n-ray means depends upon the how many types of how many different entities are there. Unary means only one entity will be in relation. Binary means two entities. N-ray means more than two. So next we have the cardinalities. In cardinalities we'll be having one to one to many to one, many to many. So this is called as my cardinality constraints in each relationship. In each relationship. So let's see the first relationship, unary relationship. When there is only one entity set participating in a relation, then that relationship is called as unary relationship. Is called as unary relationship. For example, one person marries to one person. Okay, one person is going to marry to another person. So one to one. So one person marries to another person. So this is person marries to person. So it's a unary relationship. It's a unary relationship. Next we have binary relationship. When there are two entities sets participating in a relation, the relationship is called as binary relationship. Binary relationship. For example, student enrolled in a course. Student enrolled in a course. So student is in one entity, course is in one entity. So these two are two different entity types or set. So student is going to enroll for one each course. So one student will be enrolling for a course. So it means enroll is an relationship which is of binary. Two different entities are there in a relationship. So one is student entity, another is course entity. So this type of relationship is called as binary relationship, having two entities in a relationship of enroll. Next we have n-ray relationship. When there are n entities, it means more than two entities participating in a relation. The relationship is called n-ray relationship, where we will be having more than two entities. As you can see, I have entity 1, entity 2, entity 3, entity 4. So all these four entities are in some relation. So this type of relationship is called as n-ray relationship, wherein we will be having more than two entity sets are in relation. Next we have the cardinality constraints. What's an cardinality constraint? Cardinality constraint is going to define how many times a one entity can participate in a relationship. So first type we have is one to one cardinality. First we have is one to one cardinality. When each entity when each entity in each entity set can take part only once in the relationship, the cardinality is 1-to-1 cardinality. The cardinality will be 1-to-1 cardinality. Let's assume a female can marry to a male. A female can marry to a male, right? So the relationship will be 1-to-1. One female or one male can marry, right? So here I have a relationship between two different entities, that is male and female. So male marries to female or female marries to male, right? So this is a 1-to-1 cardinality relationship. This is 1-to-1 cardinality relationship. So it means both of them, both these entities can participate in the relationship only once. In this relationship only once. So this type of cardinality is called as 1-to-1 cardinality. Next cardinality we have is many-to-one cardinality. In this, one particular entity can participate in a relationship multiple times, whereas other entity will be taking part only once in a relationship. So I will be explaining you with an example here. For example, I have a student entity set and a course entity set. Let's consider this course is provided from the university. So and students we have, so one individual student can participate into one single course. So like this, I will be having multiple students. I will be having student s1, s2, s3, s4. So it means many students will be enrolling for a single course, that is MBA. So this type of enrollment or the association or the relationship is enroll. So many students can enroll for single course. This type of cardinality is called as many-to-one cardinality. So n number of students will be enrolling for single course. N number of different students will be enrolling for different course. This type of cardinality is called as many-to-one cardinality. Next we have many-to-many cardinality, wherein for whatever the number of entities we have, all the entities or number of entities will be participating or will be having an association in relationship multiple times. I will be explaining you this with an example. I have a student entity and a course entity. For example, I am having my own private institute wherein I will be having different courses. Right? Private institute I am having wherein different courses I will be having. So the number of students will be more, right? So I am taking different students from S1 to S4. So likewise, I will be having different courses such as C, C++, Java, C Sharp, web technologies. Different courses I will be having. So students will be enrolling for different courses. So it means that a one particular student can enroll for two or more than two courses, or or two student can enroll for same course, vice versa, right? So there is no restriction of enrollment of students from course or course to student. So n number of times student can enroll to different courses, same courses, or different courses, or combination of courses. So this type of cardinality is called as many to many cardinality relationship. This type of cardinality relationship is called as many to many cardinality relationship. Let's see the quick recap of this session. What's an ER model? ER model defines a conceptual view or a design or a blueprint of a given database. So before creation of a database, we have to go for the any model. The model which we are talking here is ER model. So ER model is a conceptual view or a blueprint of a database, how our database will look like. So in this, we will be having three components: entity, attributes, and relationship. So what's an entity? An entity is a real world thing or object can easily identify, like person, place, or a concept. What's an attribute? Attributes are nothing but the characteristics of these entities. Every person will have a name, age, gender, like this. Every place will be located somewhere having its own attribute. In the concept also we will be having a different attributes. So what's an attributes? Attributes are the descriptive properties which are owned by each entity of an entity set. So each entity will be having its own attribute. Next we have the relationship. Next we have the relationship. The association among entities is called relationship. Is called relationship. So in quick recap, let's see the components of ER diagram. The components of ER diagram are three: entity, attributes, and relationships. Coming to entity, entities are of two types: strong entity and weak entity. Strong entity and weak entity. Strong entity will be having an key attribute in that, that is primary key, whereas weak entity will not have primary key in it, as well as weak entity always depends on strong entity whenever it is there in an schema or a entity set. Next we have attributes. In attributes we have key attribute, composite attribute, multi-valued attribute, derived attribute. What's the key attributes? Key attributes is nothing but a primary key attribute. Next, composite attributes is a combination of some other attributes such as address. Address is a combination of street, door number, locality, district, state, country, like this. So address will be a composite attribute. Multi-valued attribute is nothing but a phone number. A person can have multiple phone numbers. So multi-valued attribute. Derived attribute is an age. On the basis of date of birth, we can derive the age. So age is an derived attribute. Next, we have the relationship. In relationship, we have three types: unary, binary, and n-ray. Unary means only one entity set will be in n relationship. Binary means two entity set will be there in n relationship. And n-ray means more than two. So these are nothing but a degree of relationship as well. So to have this, we will be having a cardinality constraints. Cardinality constraint will define how many number of times one entity set can take part into an relationship with some other entity set. So cardinality will be having one to one cardinality, one to many cardinality, many to one cardinality, and many to many cardinalities. So these are nothing but our cardinality constraints. So in coming video, I will be discussing more in detail about different concepts of database management system. Thanks for watching this video. Thank you. Please subscribe to my channel, like and share my video. Thank you.